Welcome to your video on linear regression. Linear regression consists of finding the line of best fit, going through the points as best as it can, and it is usually done with the least squares line. So with linear regression, the data points are approximated by a line of best fit, and again, that is usually the least squares line. And I'll explain what that means in a minute. The linear equation comes in the form y equals ax plus b. You usually see it as y equals mx plus b, but they use the a in statistics instead of the m. A is the slope, just like the m was, and b is the y-intercept. So this box here is going to look scary, but don't let it bother you too much. There is an equation to find the line of best fit. This is the equation to calculate the a value, which is the slope. This is the equation to calculate the b value, which is the y-intercept. And the process that the formula takes is that each of these points has an actual y value. So this point here had its actual y value, and using the line of best fit, it has a predicted y value. So the actual y value is from the point, the predicted y value is from the line of best fit. The difference between the two of them is called the error. And the reason why it's called a least squares line is what they would do is they would make a square from each point like this. And they would add up the sum of all the squares. Then what they do is they find the y-intercept and the slope, which would cause the sum of the squares to be the lowest possible. So that's why it's called the least squares line. So you don't really have to know that for this course. I want to explain how that formula comes about and why there is a specific formula that would be used with any piece of technology. So all you really need to be able to do is to calculate the a value and the b value in order to get the equation of the line of best fit. The good news is all of the values came from the same table that we looked at last day. So this was the table that we filled out the last day. I just retyped it. And what we're going to do is calculate the a value and the b value. So for the a value, it is equal to n, which was 12. That was this value, multiplied by the sum of the xy's. And the sum of the xy's was this value right here. Because this was the x times y column, and this was the sum. And then you're going to subtract the sum of the x's. So here's the x column, here's the sum. Times the sum of the y values. So here's the y column, and here's the sum. So that's what goes on the numerator. On the denominator, you have n, which is 12, times the sum of the x squares. So here's the x squares, and here's the sum. minus the sum of the x's squared. So here's the sum of the x's, and here is the sum of the x's squared. So subtract the sum of the x's squared. And now we're going to use our calculator to figure out the numerator and the denominator. In the numerator, we get 34299, so 34,299. On the denominator, we get 44,187, and that works out to 0.7742, and round them to 4 decimal places. That is your A value. Your B value starts with the sum of the x squares, which was right here, 62903, times the sum of the y's, which was this value right here, minus the sum of the x's, which is this value right here, times the sum of the xy's, which is this value here. That's the numerator. Now, as a little shortcut on the denominator, it's equal to the same denominator as the A value. So whatever you calculated as your A value, which was 44,187, you can just put in the same as the B. When you calculate the numerator, you get 753,548 over 44,187, and that gives you 17.0536. Again, round to 4 decimal places. So the equation of your line of best fit is, this is your slope, 0.7742, x plus the B value, 17.0536. So that's your line of best fit. So if you remember from the previous day, figure out what your Unit 1 test mark was. So let's say that's your Unit 1 test mark. That's the x value. So I'm just going to use the number 70. I want you to use whatever your Unit 1 test mark was. To figure out what your predicted final mark would be, it's 0.7742 times 70 plus 17.0536. And that is equal to 71.2476, or just 71%. So that is how you calculate the equation of the line of best fit. There is your A formula, your B formula, so that's your slope, that's your y-intercept. Another thing that can cause you some shortcuts is the numerator of the A is the same numerator as the R value. So if you were answering a question where you had to calculate R and the line of best fit, when you calculate the r, whatever you get as the numerator can go in for a. So the next thing we're going to talk about is residuals, but I'm going to do that in a second video. So I'd like you to please ensure that you watch part 2 of this video. Thank you. Bye-bye.